A Skyline diagram is designed to display project plan and progress in the shape of Skyline. Excel is used as front-end program while Python is back-end program. Data are on Excel worksheet and the outcome of Python program is viewed on Excel worksheet. For Level 4 project activities. Of a selected project phase. Over defined period. On weekly basis. Referring to activities finish schedule. The Skyline is composed of buildings. Each building representing stacked activities planned in a week. The height depends on the number of activities planned in a specific week. Each floor representing a single activity with internals, that is, activity ID, description, plan total, and achieved total. Activities progress is highlighted with different colors, complete or overdue or forecast for next week. In order to create the Skyline diagram, two parts are considered. Part 1 is to read schedule data on a worksheet and construct the data required for Skyline diagram. For this purpose, we need a composite form using Python programming and Tkinter library. Part 2 is to create the Skyline based on processed data of Part 1 on an added worksheet. By now, we are focused on Part 1 in this video. Another video is planned for Part 2. Project control data are populated in an Excel worksheet with details, which project people are well familiar with, such as each activity's level 0, level 1, 2, and 3 definitions. 3 phases are considered for current discussion but can be added further as required. Each phase consists of start schedule, end schedule, plan total, and achieved total, representing activity progress. Project phase you are interested in is defined using Tkinter Radiobutton widget. Example is related to commissioning stage applied to an Australian mega project. You can select your interested level 0, then select all or only interested lower level 1 associated with the selected level 0, and so on, down to level 3. Level 4 activities are extracted from project data based on your interested higher level scopes, level 0 to level 3. The scope is selected using PMW's listbox widget. PMW stands for Python Mega Widget. In part 2 of the next video, the activities are grouped weekly referring to cutoff weekday within the period from start to finish date. Start date and end date are given referring to Excel data for the selected phase, for example, mechanical completion, when you select a project phase. X-coordinate of the Skyline diagram start from the start date, extended to the end date. Progress reference date is reporting date whose default is today's date. Activity finish date is compared with the report date to know whether activity is complete, overdue or forecast. The dates are changed using Tkinter date entry widget as date picker. The level 4 activities are grouped on the weekly basis ending at the cutoff weekday. The cutoff weekday is selected using combo box of TTK library. 3 categories for progress identification are adopted: complete, overdue and forecast, referring to the report date you need to provide. The default report date is today's date. Tkinter's color chooser widget is used for picking colors you prefer. We are using a standard application framework introduced in a book, Python and Tkinter Programming, written by John Grayson. Refer to section 8.2 of the book. The standard application framework is coded in appshell.py to support interface needs for Skyline diagram we are discussing about. The module for Skyline diagram inherits the appshell module. Before we jump to discussion on coding, we need to ensure that Python program environment is properly set up. It is assumed that Visual Studio Code is installed as Python code editor and interpreter. And essential libraries are installed: NumberPy, Pandas, XL Wings, and Tkinter, PMW and TK Calendar. If not installed yet, you can install them. To install the library, for example, TK Calendar. Open command prompt. Go to path where the package installer for Python, pip, is available. Type pip install TK Calendar on it. Here we discuss brief features of libraries essential to Python program. NumPy is a Python library and is written partially in Python, but most of the parts that require fast computation, for example for in loop, are written in C or C++. Pandas is built on top of NumPy, without which Pandas does not work. The fundamental concept of Pandas is the data frame, a two-dimensional tabular data structure with row and column based on data in spreadsheets or in relational databases. Data on Excel sheet are stored in the data frame. Pandas combines the high-performance properties of the NumPy library to apply them to the manipulation of the data frame. Excel Wings is a bridge connecting Excel with Python and makes it easy to call Python from Excel and vice versa. NumPy arrays in Pandas series, data frames are fully supported. Tkinter provides Python applications with an easy-to-program user interface. Tkinter supports a collection of TK widgets that support most application needs. Python Mega Widgets, PMW, provide complex widgets, constructed from fundamental Tkinter widgets, which extend the available widgets to combo boxes, scrolled frames and list boxes, to name a few. Using these widgets gives GUI developers a rich palette of available input devices to use in their designs. TK Calendar is a Python module that provides the calendar and date entry widgets for Tkinter. Now let's start to discuss Python coding in detail step by step. The steps we are taking are going. Starting from reference libraries and module. Creating application class inheriting app shell and its attributes. Define widgets inside the data area. Extend functionalities of the standard application framework embodied in app shell. Finally, execute the application. The text between the triple quotation marks is called a docstring in Python. By convention, Python programmers use docstrings to provide specifications of functions. These docstrings can be accessed using the built-in help function. To allow an intended program to access reference libraries, modules, and objects from other modules than Python own, we need to import them. NumPy is not referenced in the application explicitly, but to work with Pandas, import NumPy with an alias, np. Pandas reads Excel data and stores it in the data frame. Pandas combines the high-performance properties of the NumPy library to apply them to the manipulation of series and data frame. Import Pandas with an alias, pd. Excel Wings is selected to play a bridging role in connecting Excel with Python. Import Excel Wings with an alias, xw. Import all modules in Tkinter library and specific modules using the syntax. From Tkinter import asterisk and import ticks, ttk, and color chooser. TK Calendar is imported for date picker. Python Mega Widgets provide complex widgets, constructed from fundamental Tkinter widgets, which extend the available widgets to scroll list box and so on. Python Mega Widget, PMW, is imported to use PMW widgets. AppShell is the superclass of the program we are discussing. Thus, we need to import the AppShell whose attributes are inherited or overridden. A subclass, Skyline diagram, is created as a placeholder, to be called by application. Therefore, it is required to import the class. Import Skyline diagram. The application we are discussing uses the standard application framework offered by the module appshell.py. The class Skyline GUI inherits attributes from its superclass, AppShell, including all of the attributes that AppShell inherited from its parent class, that is, PMW.MegaWidget. In addition to what it inherits, the subclass, Skyline GUI, can add new attributes and override attributes of the superclass, AppShell. We define the application class, inheriting from AppShell and overriding its class variables. Set useCommand area to 1 to use the command area of the standard application framework where buttons are defined. Title of the application. And so on. The first thing to do is for Python to read the Excel data. Data on the worksheet consists of Level 4 activities with corresponding hierarchical definition, Level 0 to Level 3. schedule and progress data for 3 phases are given and the data are supposed to be updated weekly. It is assumed that the Excel file is left open, in other words, active, and worksheet containing the project data is selected, in other words, active. Establish a connection to the working Excel file using Excel wings. To connect with Excel file, use books.active method to instantiate the Excel file. Then instantiate the data worksheet by using sheets.active method. Read Excel data using Panda's read Excel method with the name of Excel file, sheet name, and start row by specifying skip rows. Project data starts at row 2, requiring skip rows equals 1. Store the Excel data in a Pandas data frame named self.df. Now, we are discussing how to develop an application GUI. The data area is already defined as a master to contain a group of widgets which will be handled by a geometry manager. We set the data area to a variable, data area, using the interior function defined in app shell. Data area equals self. Interior. To facilitate data area layout, we will define 4 subareas. Each contains their own group of widgets. The container is defined by frame widget. We define 4 frames using Tkinter frame widget inside the data area, handled by a grid geometry manager. Frame 1 at top left, for project name, using entry widget. Frame 2 at top right, for phase selection, using Radiobutton widget. Frame 3 in the middle, for scroll list boxes widget. Frame 4 at bottom, for schedule data and progress colors. The frames are anchored within the available space fully by setting sticky equals NWSE. Frame 1 contains 1 label widget and 1 entry widget to enable project title to be specified. Both are contained in Frame 1 and handled with Packer Geometry Manager. A label widget is defined to display text with project as text. An entry widget is defined to collect input from a user for project title. To offer a default project title, file name plus Skyline diagram, to entry widget. First, create a new string var object e equals string var. Second, assign the string var object, e, to the text variable option of the entry widget. Third, give the default value to set method as an argument. Balloon widget is defined to pop up tooltips for the entry widget. The balloon widget is supported by the Tkinter.tix wrapper. Bind balloon widget to the entry widget by using bind widget method and specifying tooltip message to the balloon message option. It is necessary to select one execution phase. For this purpose, we use a group of Radiobutton widgets. A radio button, sometimes called option button, allows the user to choose, exactly, one of a predefined set of options. All selections are exclusive, so that selecting one button deselects any button already selected. The Radiobutton widget is handled by Grid Geometry Manager. Each Radiobutton is assigned to different value so that a chosen Radiobutton is identified by getting the value of the chosen Radiobutton. To find which Radiobutton is selected, we associate all the Radiobuttons in a group to a single variable. The single variable is defined by creating a new intvar object, var equals intvar. var.get method returns the value of the selected Radiobutton. As a default, Radiobutton 1 is selected using set method, var.set 1. Radiobutton text is based on Excel data and the text is sliced to limit to 10 digits by entering range in square bracket. Callback function, radiocell, is assigned to the command option. The callback function returns a start date and end date corresponding to the project phase identified by the chosen Radiobutton. Start date is the earliest date of planned schedule of the selected phase and is computed using min method. End date is the latest date of planned schedule of the selected phase and is computed using max method. The type is timestamp. The start date and the end date are assigned as a default to the date picker widgets contained inside frame 4. The details of the date picker widget are going to be discussed below when we discuss the frame 4. Frame 3 contains 4 PMW scrolled list boxes. Level 4 activities are extracted from project data based on higher level scopes. Level 0 to level 3 you select. You need to be able to select a level 0 element, then select all or part of lower level 1 associated with the selected level 0, and so on, down to level 3. We are using PMW's scrolled listbox widget to do so. The scrolled listbox widget is a convenient widget providing a listbox widget with associated horizontal and vertical scroll bars. Firstly, we need to find all unique level 0, level 1, level 2 and level 3 IDs. All IDs of a level are produced by selecting a single column of a data frame by specifying a column name within the square brackets. For example, self.df with lev0 inside square brackets returns a sequence of level 0 IDs of all rows including duplicates in the type of series. We will have unique level 0 IDs by transforming the series to a set. Sorted method sorts the set of the level 0 unique IDs in the ascending order. Then define scrolled list box for level 0 by calling lev0box method with the sorted unique level 0 IDs as an argument. In a similar way, define scrolled list box for level 1, 2, and 3 IDs. For scrolled list boxes are defined using PMW's scrolled list box widget. Items to be listed are all sorted unique IDs. Select single item for level 0 list box and multiple items for other level list boxes. Only vertical scroll bar is included. Bind callback function to one selection or double-click. Handled by Grid Geometry Manager. The export selection option, when set to false, is to keep selection when clicking elsewhere. Define PMW balloon widget and bind balloon widget to the listbox 0 by using the bind method, not bind widget method, which is for Tkinter balloon widget, and specifying tooltip message. When an element in a listbox is selected, a binding callback function is triggered. The callback function is intended to refresh list boxes of lower levels. For example, level 0 callback function is refresh level 1, 2 and 3 list boxes according to the selected element of level 0 list box. Level 1 callback function is refresh level 2 and level 3 list boxes. Level 2 callback function refreshing level 3 list box. Select rows by writing a logical expression with the isIn method included inside the square brackets as the index of lock property. That expression is then evaluated on each row of the data frame, and the rows for which it evaluates to true are selected. In case of level 0 callback function, find the selected element from level 0 list box using the getCurrentSelection method. From data frame, self.df, find level 1 ID, level 2 ID, level 3 ID of the rows where level 0 ID is the selected element. The logical expression is written inside the square brackets as the index of lock property, lock, self.df, lev0.isIn, cells 0. Refresh level 1, 2 and 3 list boxes based on new ID. In case of level 1 callback function, find selected element from level 0 list box and selected elements from level 1 list box using the getCurrentSelection method. From data frame, self.df, find level 2 IDs, level 3 ID of the rows where level 0 ID is the element selected from level 0 box and level 1 ID is the element selected from level 1 box. Refresh level 2 and 3 list boxes based on new level 0 ID and new level 1 ID. In case of level 2 callback function, find selected element from level 0 list box, selected elements from level 1 list box and selected elements from level 2 list box using the getCurrentSelection method. From data frame, self.df, find level 3 ID of the rows where level 0 ID is the element selected from level 0 box, level 1 ID is the element selected from level 1 box and level 2 ID is the element selected from level 2 box. Refresh level 3 list box based on new level 0 IDs, new level 1 ID and new level 2 ID. Level 3 callback function checks whether all the higher level list boxes are selected or not. If all the higher level list boxes are selected, turn OK button to normal, that is, enabled. Inside frame 4, 3 date pickers, 1 combo box and 3 color pickers are located. 3 date pickers are for start date, end date, and report date.
The start date and end date are to define the Skyline diagram x-coordinate range. The report date is used as the progress reference date to tell whether level 4 activity is complete, overdue, or forecast. In this program, we use date picker functionality rather than entry widget. We define 3 date entry widgets of TK calendar module. Date pattern is defined as per Australian Standard, DDMMYY. You can change the date pattern to suit your date pattern. Default dates for start and end date are coupled with a selected project phase. The project phase is selected using Radiobutton inside frame 2 we have discussed earlier. The start date is the earliest date of plan schedule of the selected phase and is computed using min method. The end date is the latest date of plan schedule of the selected phase and is computed using max method. Today's date is the default date for report date. You can change the default dates and pick your date. This is what the date entry widgets are capable of. It is assumed that project reporting is made weekly, based on the progress achieved by cutoff weekday. We define TTK combo box widget with built-in entry field and an associated scrolled list box. The scrolled list box is displayed beneath the entry field when the user clicks an arrow button on the right of the entry field. The default is Friday, which is set using the method current. You can change the default weekday to your project need. Balloon widget is defined to pop up tooltips for the combo box widget in the same way as other widgets. Three progress categories, complete, overdue, and forecast, are distinguished with different colors on the Skyline diagram. We define 3 button widgets and bind each button to function containing color chooser as color method. The chosen color turn on button's background. If you want to change default color which is set using configure method, click button to pop up color chooser and select your color. The button background color is changed to your selection. Balloon widget is defined to pop up tooltips for the button widget in the same way as other widgets. We define 2 buttons using the button add method of app shell inside the command area. This overrides the command area of app shell. A button widget is a label that reacts to mouse and keyboard events. We bind a method call or callback that is invoked when the button is activated. 2 buttons are defined using the button add method of app shell, OK button and close button. OK button is bound to a method self.createSkyline that is invoked when the button is activated. OK button is disabled to prevent the user from activating the OK button as a default. OK button is enabled when required conditions are satisfied. Close button is invoked to quit the application. We discuss here how to view the standard application framework by creating the standard areas such as title, menu bar, data area, and command area defined in app shell, and add applications functionality we have discussed above and override the attributes of the app shell. As you can see, the __ create interface method creates each of the standard areas and calls the create interface method in app shell class. Therefore, it is necessary to create the create interface function in application program by addressing app shell's interface method, applications methods such as read data, create main, and create buttons. Lastly, we are discussing how to collect your input on Skyline GUI and how to construct the data required for Skyline diagram based on your input. A starting point is to activate OK button inside the command area. The default state is disabled. When you complete your input, the OK button turns to normal state, ready for your activation of OK button. Once OK button is pressed, a function named createSkyline is called. Get data from the application we have discussed so far and store the data required for creating Skyline diagram in a dictionary named readFormData. Call a class named Skyline diagram, which will be complete for the next session. Create a dictionary named readFormData defined in callback function, formData. Start from first item presented in key value pair written with curly brackets. The key and value is separated by colon. Add next item consisting of next key and next value in pair. The next key is an index of the dictionary, readFormData, and the next value is assigned to it. Repeat this process. Get widget data. Labels text using cGet method with text as argument. Entries value using get method. Radiobutton's name using cGet method with text as argument. Listboxes selected items using getCurrentSelection method. Date entries date using get method. Selected combo box value using get method. Buttons background color using cGet method with background as argument. Pass the collected data and original data frame to the class Skyline diagram, dedicated to generating a Skyline diagram. Whenever the class is instantiated, a call is made to the init function defined in that class. A new data frame is generated only for level 4 activities as selected using the isIn method.
By now, we have yet to create user interface in the front-end program, that is, Excel. Instead, we run a program in the back-end program without creating any user interface. Custom user interface on the front-end program, Excel, is discussed in next video when we discuss how to view project Skyline diagram. Excel file is active and run Python program using Python interpreter with application's main module, Skyline GUI.py left active. Creation of the Skyline diagram on an added worksheet is a task to be discussed in next session. Download the program for your use and give feedback. Feel free to contact me. Before you move out, your subscription to my YouTube would be highly appreciated.